So do you all, I guess there are no questions from the last class, right? Or do you have any questions from the last class? Okay, so let me briefly go over whatever we discussed in the last class. I think I'll review some of the slides that we have already, that we went over in the last class, and then I'll continue with exceptional handling again in this class. Okay, so we looked at 3 or 4 keywords, right? So one was try, catch, finally, and then there is this throws keyword, which we'll look at it later. But so if you have a piece of uh, code in your entire code, but you have a piece of block, let's say a block of code, which needs to be monitored, which you suspect that there could be a runtime error in this block of code. So that block of code needs to be monitored, and you can monitor that block using this try keyword, right? Try followed by the opening and closing braces, right? So every piece of code or block of code that needs to be monitored should go inside this try block. Now, if at all there is an error, runtime error, you need a way to handle it, right? So catch block is meant for handling those kinds of runtime errors. So those runtime errors are what are called as exceptions, and there are different types of exceptions, right? But each catch block can handle only one type of exception. So we can have multiple catch blocks to handle multiple types of exceptions. So we have some examples later on, but so that's the purpose of the catch block, right? And then we have this finally block. So try is always followed by catch block, and it is not optional, right? So you always should follow try with catch, but finally is optional. You may or may not have finally. But if you do have finally block, it should be after catch block and or all the catch blocks. And again, it's a block. You can have a set of statements inside this finally block, right? And the purpose of the finally block is to it's generally used to release any resources that you have acquired, majorly in the try block or just before the try block. So let's say you have acquired some resource, which is a file handle, for example, right? And in your try block, if everything goes well, finally gets executed, and in the finally you release your file handles. So finally gets executed irrespective of whether there is an exception or not, right? So if there is an exception, catch block handles it and then finally gets executed. If there is no exception, then statements in the try block gets executed, and then there is no catch block gets skipped and you have finally. So statements in the finally state block gets executed, right? So going back to the file handling case, so you need to release the resources irrespective of whether there is a exception or not. Right? So even if there is an exception, you still have to release those resources, right? So that's why generally all these memory release kind of statements are put in this finally block. So let's just go over the sequence or the flow that I just described. Okay. So you have your try block that monitors this block of code for possible runtime exceptions, and if there are no exceptions, after the try block, the finally block gets executed, and then you move on to the next statement. Let's say you have your statement 2. There are these statements, and there is some exception in statement 2. So if there is an exception, it is handled by the catch block, and after the catch block gets done, your statements in the finally block gets executed. So after that, you go to the next statement. So that's how the flow of control goes, right, in your try, catch, and finally blocks. Are there any questions so far? Okay, so
Repeat when finally block gets executed.
Sorry,
I
can you
did not
repeat your
understand.
question?
Sir, can you just repeat when finally block gets
Okay,
executed?
okay, sure. So finally block gets executed irrespective of whether there is a exception or not. So if there is no exception, then every statement in the try block will get executed, and after that it comes to the finally block. So it will skip the catch block because there is no exception. But let's assume that there is an exception. So so let's say that occurs in statement 2, as was shown in the example, right? So if it occurs in statement 2, then statement 3 will never get executed because there is an exception. So from statement 2, it will jump to the catch block, the corresponding catch block, um, and all the statements in the catch block will get executed like this. And after that, the finally block will get executed. So finally block gets executed irrespective of whether there is an exception or not.
Okay, sir. Thank
So is
Excuse me,
that
sir.
clear? Yeah.
So then, what would be the difference between the statements that have been executed in the finally block and the statements that are executed after the whole try catch finally block? In this is the next statement.
Hmm. So in your catch block, you don't. Okay, so we'll be looking at this another keyword called throws. Right. So for example, in your throws, you can have throws in your catch block also. So when that happens, the control will never will not come to the next statement, right? So, but it will still execute finally block. So you have your throws here. So you are rethrowing the exception to the caller. So you're saying that the caller should handle it. You handle some part of it, and you are letting the caller also to handle the other part of the exception, right? So you can do that. So in that case, this next statement will never get executed, but the finally will get executed.
Okay,
So
thank you so
irrespective of
much. Yeah.
whatever happens, the finally is always will always get executed.
Thank you,
So
sir.
that's the difference. Yes. So any other questions? Okay, so let's move on. Okay, you have a piece of code here. The first statement is just a print statement, but using scanner, you are trying to get the input from the user. You are expecting an integer input, and that's why you are also trying to convert this input into integer, and that's what this sentence does, right? It will take whatever is the input that was given on the terminal, and it will convert that to an integer. So if you look at this program, right, and if everything is if everything goes well in the ideal case, then this is correct. But it can happen that the user may not put in an integer. It can be a string, or it can be like a complex number or whatever, right? So there are other possibilities that the user can put in, and if that happens, then there'll be an error. So you're trying to cast, for example, a string to a integer, and that's an error, right? So the program, although in terms of the behavior, it is correct, but it is not taking care of all the possible inputs that the user can provide, right? So let's see. So for example, like I said, if it's a string, then it will give an error. So in order to safeguard this program from all those different inputs, so you can make use of this try and catch block, right, as well as this loop. So the loop is it serves a purpose that as long as you don't provide integer, it will keep asking you for input, and when you do provide the integer as the input, it will stop. Okay, so there is a possibility that in this block of code, a runtime exception can occur, and it will occur if it's not an integer, right? So that's why you enclose this in the try block, and now you have your catch block. So the scanner will give out the input mismatch exception if it is not of what you expected. So you're expecting integer, and if it's not, then it will give out this exception. And if everything goes well, and if you are the user gives the input as integer, then you are done. You don't have to loop through. You don't have to go to the next iteration, right? You're done with the loop. But if it's an exception, you say that it's not what you're expecting, and you can say that you are looking for a integer, and then it will go back and ask again, right? So if it's an exception, this block will get executed, and after that you have your finally, which will always get executed, and then it will again ask for the input from the user, right? So this takes care of all the possible inputs that the user can provide, right? So let's move on. So let's say you have this array of strings, right, that has different values in it. It's a mix of strings, numbers, which are in the form of string, and null as well, right? So this is an example, but if you're here, we are iterating over the string, but it is past the indices. So here we have 5 elements in the array, but we are iterating until 10, right? 0 to 9. So you are iterating over it, and you are calculating the sum. You are calculating the sum, but before that you convert that each of these elements into an integer, and then you calculate the sum of each integer. So here there are multiple issues, right? So one is that not all of the elements are integers. They cannot be converted to integers, which is the number format exception. The second issue is there's also a null here, and if it's a null, then it will give the null point exception. And the third issue is that you are going past the index, maximum index that is possible, which is 4, right? It's from 0 to 4. But here you are going until 9. So there are multiple different exceptions that could occur here. And that's the whole point of this code, right? So we are trying to show that from the same piece of code, multiple exceptions could occur, and there should be multiple different catch blocks to handle all these different types of exceptions. So we have 3 catch blocks here that are supposed to handle 3 different types of exceptions. Right. So the first element will give the number format exception because you are trying to convert a to an integer. The I equal to, which is the third element here, this is null, right? 0, 1, and 2. So null would obviously give the null pointer exception. And the last one would be you're going past the indices, so it will give another index order. So the convention is that you have multiple different catch blocks, and right at the end you have a catch-all block, which is where you say that the type of exception is exception. So the name itself is exception. So that's the parent class for all the exceptions. So whatever is the exception, it will get caught. Right. So you start with specific types of exceptions, and right at the end you have a catch block that will catch the general exception. Right. So that's the general convention. So any questions on this one?
So the last block which you talked about, the catch-all block, the name is catch-all or catch and in bracket exception E.
Right. So yeah, it's the second one. So it's catch, and then you have exception. The type of exception is exception, which is the superclass for all exceptions, and then the variable.
Okay, thank you.
But yeah, it's a catch-all block, so it will catch all types of exceptions. Okay, so let's go to the other example. So here you have S, but you are initializing it to null. So this will straight away give rise to a null pointer exception, right? But before we even go to the running of the program, do you think there is any compilation error that will come up here? So do you have any guesses as to whether there would be any errors or not?
Catch should be immediately after the try block.
Right. So catch should be immediately after the try block, and there cannot be any other statements in between try and catch. Right. So the answer to that is the second one. So no statement is allowed between a pair of try and catch. So once you resolve this, yeah, then you will get this runtime error, which is the null pointer exception. Right. Okay. So you can also have nested try catch, meaning that inside the catch you can have try and catch again. So an example is given here. Let's say you are requesting Wendy to get a drink. Right. So if everything goes well, then yeah, this is okay. But if it turns out that Wendy is null, right, then you get this null pointer exception. And then if in that case you are firing Wendy and you are making this request again. So you are asking Johnny to get a drink. And again, if Johnny is null, you get this null pointer exception, and you are firing Johnny, right? So the takeaway is that within the catch block, you can also again have try and catch, because there can be exceptions. So you may have a set of statements within the catch, and those one or more of those statements can lead to an exception, right? So this piece of code might also have to be monitored. So that's the nested try and catch. And yeah, this is what I was referring to. So you can methods, instead of handling exceptions, they can throw it out so that the caller should now handle it. So let's say an example is given here. Right? So you have your drink water method, and inside your drink water, you are calling the get water method. But you are monitoring this get water method for possible exceptions. And here you think that there's a possibility that it will throw the null pointer exception. Right. So now you make a call to get water. The control comes here. It will go over this statement, the first statement. And if water is null, right, then you fire Wendy, you instead of handling this exception here itself. So if you want to handle it here, then you have to have the try and catch here, right? But if you don't want to handle it here, you can simply throw it. So the way to throw it is using this keyword called throw, and then creating an instance of the appropriate exception type. So here, since it's a null, you are creating an instance of the null pointer exception with a possible message. So message is optional, but it's always a good practice to send a message, right? So that users can understand why there is an exception. Right. So in this case, you're saying that there is no water, and that's the message that you are passing. So once you throw it, it has to be caught by the caller. So since drink water is the caller for get water, drink water has to catch it. So now it's up to the drink water whether to rethrow it or handle it. Right. So if it has to handle it, then there should be a try catch block, or it can rethrow it further. So if it rethrows, then if there's a method that called drink water that has to handle it, or the program will end abruptly, because there's no one handling it. So it's a runtime error, and the program would end abruptly, and it will simply print the messages, stack trace. So the stack trace here is that let's say in the main method you call drink water, and drink water calls get water, and get water throws it back. So you again come to the get water, and from in get water, let's say you don't handle it, and that's why there's an exception. So that's the stack trace. It's a list of all the method calls. Right. Okay. And so why do you want to do this, right? So there can be a question as to instead of handling the try and catch, exception here itself, why should you throw it? So this is generally done if you have certain preconditions, and one or more of them is not met. Right. In that case, you want to let the caller know that there is an exception. Right. So if you silently handle it, the caller may or may not know. Right. So The only way to know is, let's say, whether, say for example, in C language, you will return some return type, let's say -1 or something like that, which indicates that not everything went right. But you cannot exactly say what went wrong, right? Even in C language, you can't do that. But here, if you create an instance of null pointer exception with a message, you would be able to say that what exactly went wrong, at least give some idea to the user. And you are also saying that something actually went wrong by throwing this exception. So yeah, that's the advantage of not handling it within GetWater. Right? Did you understand this, or are there any questions? Okay. Yeah. So if there are no questions, then let me move on. Okay. So I already got that. So we already talked about rethrowing it, right? So so the other version is you handle the exception here itself, but you are rethrowing it again. So for example, one advantage of handling it here and then rethrowing it is you can log it. So it's always a good idea to log all your major errors, right? So so for example, instead of system.out, you can have a log statement saying a log.print, for example, and then put into log whatever is required to diagnose this error, and then simply throw it back so that the caller knows that something did go wrong, and now it's up to the caller to respond to it. So for example, the caller can say, can pass a proper input now. Let's say GetWater takes some input, right? So, and the input was not correct. So now the caller can call GetWater again with a proper input, with a valid input, right? So you are giving the option of handling the exception to the caller, and the caller can do whatever it wants to. So here you are combining both of them. You are handling it here and throwing it back to the caller. Right, and like I said, this can go on. So for example, you throw it to the caller, and within within Drinkwater, it need not handle this exception again, and it can rethrow it. So if it is rethrown, then it should be handled by the caller of Drinkwater or the JVM if there is no caller.
Sir, what is the difference between these two files?
Sorry, your voice is very low.
What is the difference between these two programs?
So this one and the previous one, is it?
Yes, sir.
Why is it? Okay. Right. So this is the previous version. So in the previous version, you did not handle it here, but you are simply throwing it to the caller. And in the current one, you are handling the exception here in GetWater, but you are still throwing it back to the caller. So you may want to do this. Like I said, I gave one example, right? Let's say you want to log the details. So let's say something went wrong here, and you want to log those details. So all these details are present only within this method, right? So for example, you don't get access to Wendy in the Drinkwater method. You don't get access to volume in the Drinkwater method. So all these variables are within GetWater. So you can say log all these statements, saying that these are the values and this is why it may have led to an exception. And then let the client know that there is an exception. So for that, you throw the exception back to the client. Back to the caller, saying that okay, there has been an exception, and now you can handle it the way you want. So, for example, one possible way of handling it is calling this GetWater again with a difference in the inputs. So, in this case, it doesn't take any arguments, but let's say it takes 3 arguments. So, in the first attempt, you passed a null to one of the arguments. So that could be a reason for the error. Right? So you may want to rectify that and then call GetWater. But how you handle this exception is now the responsibility of the caller. Did that help?
Yes, sir. Thank you.
So let us get back to this try catch program execution, tracing it. So I think so the difference here is that there is a throw statement in one of the catch blocks. Right? So let's see how the execution happens. So you have your statement 2, and then let's say statement 2 gives out an exception, runtime error, and the type of exception is exception 2. So that's why it should go to the second catch block, right? So then it will go to the second catch block. It will execute all the statements before the throw. And after you throw it, right, you cannot further go on with other catch statements, which we will see here. So that's why before throw gets executed, all the finally statements are executed, and then the throw will get executed. Because if you execute throw, then the control should go back to the caller, right? But earlier we said that whatever happens, all the statements in finally block will get executed, right? So before the control leaves this particular block, it has to execute finally. So that's why it will execute finally, and then it will come back to the throw. So first it will handle all the run all the statements to handle the exception. Then it will execute finally, and then it will throw the exception. Right?
Sir, throw basically helps us to give message where the error is being placed.
Sorry, error is being placed.
Where the error is happened basically.
Right. So yeah. So it gives two messages. So first one is that there has been an exception. Second message is that now since there has been an exception, you handle it the way you want. So now caller has to take care of both the things. So caller should first recognize that there has been exception. So they should provide either try catch or rethrow it. And the second one is they should come up with a mechanism to handle this exception that you have thrown back to the caller.
Okay, sir.
No. No, thanks. Okay, so now let's see how these exceptions are handled. Right? So I already briefly talked about it. So let's say you have this series of calls. So you have method A, and inside method A you are calling method B, and inside method B you are calling method C, and C calls D. Right. So if you have these all these method calls are on the stack frame, because after D gets executed, you go back to C, and after C is done, you go back to B, and so on. Right. So it's a last in first out, and that's why you have stack to represent this. So now there are two other important terms here. One is callee and the other one is caller. So let's say if A calls B, then A is the callee. Sorry, A is the caller and B is the callee. A has called B, right? So A is the caller and B is the callee. So now let's see what happens when there is an exception. Right? So in each frame, so you can take this rectangle as a frame in the stack. So that means it's a one slot in the stack, right? But we call this slot as a frame, and frame can store local variables that are part of this A, for example, input parameters and return values and intermediate values. So everything that is all the current state of A would go on the stack, and it will call the method B. And if method B calls method C, then the current state of method B would get stored on the stack frame, and C gets called, right? And that's how this proceeds. So now, along with these regular variables, you also have this exception table. So it stores information on where is this try catch and finally block within A, right, or within B or C. Okay, so let's. So whenever an exception is thrown, So the first thing that happens is, let's say the exception was thrown in C. So it will first check in C itself whether there is a catch block, right? Whether there is a way to, whether C has provided any mechanism to handle this exception. So if it has provided some mechanism, which is a try catch block, it will execute that. If it hasn't, then it will go to the caller, its parent, right? So for example, C has, so there's an exception in C, and C did not provide any exception handling mechanism, right? Then it will go to B. So in B, it will again check whether there is a mechanism to handle this particular type of exception. And if there is nothing, if B does not provide, then it will go to A. And if A also does not provide it, then it will be handled by the JVM, but it will result in an abnormal termination, right? So, and once it, if at all there is an abnormal termination, then it will print out this stack trace. It's a method call. So stack trace, as the name says, it will simply print the number of lines. Sorry, the number of number and then the line indicating that where the error has happened.
Sir,
So,
I had one
yeah.
doubt regarding, sorry, sir, to interrupt.
Sure, yeah,
But
go ahead.
so let's suppose in C, there is a null point error happened. So C has a handling for this null point error. B also has this handling for null point error, and A also has this handling for null point error. So will C's handler will get executed, B's or A's handle will get executed?
It is C's in this case. So the first priority would be given to the method in which the exception has occurred. So in this case, C, let's say in C there is a null pointer exception, and if C has provided a mechanism to handle it, then that it C, it's the C's responsibility, right? So the exception will get handled at C itself. But if C did not provide, then it will get escalated, right? So it will first go to the parent, which is B, and if B also does not handle it, then it will go to its parent, which is A. And if A also does not handle, then it will go to its parent, which is the JVM itself, right?
Okay.
So that's the mechanism. Any other questions? Okay, so let's move on. Oh, okay. So there are two types of exceptions. One is called the checked exception, and the other one is called the unchecked exception. So the one here in blue, those are the checked exceptions, and the parent for all the exceptions is what is called as throwable, right? But so checked exceptions are the ones that can be handled in some way, and some examples are these null pointer exceptions or class not found, clone not supported, which we have seen earlier, IO exceptions, and so on, right? Or index out of bounds. So these can be handled in some ways, but unchecked exceptions, it's not up to the user to handle it. So an example is out of memory error. So there's no way, whatever you do, you cannot reclaim the memory, right? So it's up to the runtime and JVM to handle it. So you cannot handle these kinds of errors. So other one is stack overflow. So again, you cannot handle these kinds of errors, right? So maybe, for example, in stack overflow, it could be your something could be wrong in your program. You can check that, but you cannot handle it at runtime very easily, right? So that is the difference between checked exceptions and unchecked exceptions. So these are runtime errors that is not generally caused by the programming, the program that you have written, but there could be external factors, and you cannot handle it in your program. So you cannot provide try and catch blocks and handle it. Right? Oh. So you cannot do much, and that's why there is no use in handling these unchecked exceptions. So you can handle the checked exceptions, right? So those are the two types. So now then the question is, how do you handle these checked exceptions? You can do so by using this try and catch block. So let's say you have a piece of code here again. You are creating a file reader based on a file name, and you are trying to read the file. So what can go wrong here? Right? So one of the aspects could be that this whatever file name that you have specified, it does not exist. If it does not exist, then you will get an error, right? A runtime error. So there's a need to wrap this code inside the try block and then monitor it for possible exceptions. Okay? So here are some statements that can result in exceptions, right? Let's say the file does not exist, or the file was not it was not closed properly, and so on, right? So there can be multiple reasons why there could be an error here, or like I said earlier, file does not exist. So in all these cases, there can be an exception runtime error, and you have to provide a mechanism to handle all these kinds of exceptions. So yeah, we have already seen throws. So you can either handle it here or throw it, right? But if you are throwing it, then you need to specify it beforehand. So this says that there is a count chars method, and it throws these two types of exceptions, which is file not found and IO exception. So there is a possibility that either of or both of these exceptions could be thrown in this piece of code. And you're also saying that you meaning the count chars method will not handle it. Whoever is calling this method should handle it, right? So what is the output of this program? Not one of you can unmute and let me know the answer. Okay, someone. Okay, so let me go ahead. So here the error is that one of the catch block is unreachable, and it is the second one, right? Because if the first catch block itself is a very general one, which is exception, right? As we noticed earlier, the class that is at the right at the top is exception, right? So whatever is the subtype, it can easily be handled by the exception variable. Right. So like I said earlier, this is the catch-all block. So catch-all block should be placed right at the end. So if you place it anywhere else, then you cannot catch the specific exception. So even though, let's say if it's null pointer exception or array index out of bounds exception or number mismatch exception, it does not matter. It can catch all exceptions. So that's why you should put this right at the end, right? Any questions so far?
So I want to ask that if the exception block catches the error, so we don't need a null point exception block. So why is it an error?
Right. Oh, it's okay. So it's not a syntax error, right, or compilation. So it's an error in terms of the good practice.
Logical
so
error.
So let's say, kind of logical error. But yeah, in terms of logic also it's okay, but you are just violating that good practice, right? So for example, there was an null pointer exception. Just use the plain exception and catch it. You would not know what was the cause of the error. right? You may
Okay.
print the stack trace, but unless you figure out the exact type of error. So exception can even catch either it's array index sort of bounds or say number mismatch or whatever error. Unless you are specific, you don't know the type, and that will help you in the debugging, right? So as far as possible, it
Okay.
is better to first use the more narrower exceptions first, and then put the. Okay, does that help?
Okay, sir.
Yeah. Any other questions? Screen seems to have freezed. Okay.
But sir, here the answer where it is written compilation error, it would not actually give a
Right.
compilation error, right?
Oh, that's a good point. Um, yeah, so it is actually a compilation error because so it's like saying return X, and then after return you have a few statements. So you have a method, and somewhere, let's say in your third line, you say return X, but in your fourth and fifth line, you are still doing some computations. There's no point in doing it, right? It's unreachable code. It will never get.
So, but the first catch block would be executed. So catch block 1 should be printed, right? And why would the compilation error then come? Like that class catch block is not reachable. So why would the compilation error come then? Even though it's not reachable, like we
It's
caught
just
that
a
exception in
indicator,
the.
right? So it's not. So if you look at it in the strict terms of it, it's not a syntax error. So, and I think that's why you're saying that there should not be any compilation error, right? So although syntactically it's right, uh, but there is an error in. So it's just an indicator to the programmer saying that you have written something that is not useful. Because
Okay,
it will
so
never get executed, no matter what the combinations of statements that you put in. It's never going to get executed. So maybe there is something wrong in the way you are designing this flow of control, right?
okay, sir. Thank you, sir.
So from that point of view, it's just a hint to the programmer in terms of the compilation.
So sir, it's like a warning.
Yeah, so that's right. So it's a warning, but it's not a, unless you resolve it, it will not go ahead. But in terms of the severity, you can take it as a warning, because most likely there will be something wrong in the way you have designed the flow, right? And that's why it has ended up there.
Okay, sir. Thank you.
Yeah. Okay. So, any other questions, or shall I move on? Okay. Nice. Yeah, it is switching slowly. So, there are a few methods in this throwable class, right? So you have your throwable, and if you remember, so a couple of slides back, I said throwable is the parent class for all the exceptions. They can be either checked exceptions or unchecked exceptions. So for checked exceptions, you have exception as the parent, and for unchecked exceptions, it's the error, right? So error is the parent. But you have some methods which are common to throwable, so which are part of throwable, and that's why they get inherited to all the exceptions. So the ones that are of interest to us are the toString, which returns a short description of the exception, and then the get message. So it actually gives out what the, if at all there is a message, then you can print that message. And finally, you have your print stack trace. So that will simply print out. So an example is given here, right? So this is the print stack. So it will give out the line and the file number, line number and then the file name. So let's go over this example. You have your drink water, and drink water calls the get water. And within get water, let's assume that you make a call to Wendy. You request Wendy to get a drink, but that results in a null pointer exception. So when executing this statement, it immediately realizes that there's an exception, and then it comes to the catch block. And within the catch block, you are printing the stack trace. So it will start right at the top of the stack, right? So at the top of the stack, you have your current statement. So Andy dot, okay, I think, yeah, okay, the numbering system is messed up. So you have 1, 2, 3, and then 2, 3 again. Okay, so it should have been, okay, I'll fix this later on, but so you have, this is your 8th line, right? Your Wendy dot get a drink. So that has resulted in null pointer exception. And now you go to the next element in the stack, which is the caller of this particular method. So in this case, it's drink water, right? And drink water has called get water in line number 3. So this should also be changed, but assume this is the line. And for now, just take it as 3. So that's why you end up with 3 here, right? So, and if drink waters was called by some other method, that would appear here. So it will go over the entire stack. It will pop out each element, and then it will print out on the either the screen, or if you put it in a log file, it will put it to the log file or write it to the log file, right? But it will pop out each element, and then it will display it, right? So it starts with this particular line. Then it will go to the next element in the stack, which is the caller of this method, and that is drink water. Any questions here? So print stack trace method is pretty useful, right? So whenever there's an exception, I think the least that you should do is definitely print the stack trace and the message that comes with the exception. So let's go on. Okay, so let's look at this issue where so one of the methods that you have in your class that doesn't handle the exception, but it simply throws it. So it's now up to the caller to handle the exception. So what happens if you override this particular method in the subclass, right? So there's a class called cloning, and it has create clone method, but it is throwing the clone not support exception, right? So it's not handling it here. Now you have a subclass called human, which is extending this class, and you are overriding it, right? So the question here is, when you override it, should you still throw it, or is it okay to handle it? So in this case, if you are overriding a method that is throwing exception, it is not required that the overriding method, which is create clone in the human class, should also throw it. So it need not throw it. It can either catch it, or if you want to, it can throw it again. Right. So in the subclass which is overriding it, you don't need to throw it. So let's see a few other variations. My screen is too slow. Okay. But let's see the reverse, right? So in your cloning class, you have a method called create clone, and that does not have a throws part. But in the subclass, you're adding the throws. So I'm waiting for the screen to change. Okay. So this is not possible. So you cannot have it in the reverse. So if you have the parent class cloning, and there's a method called create clone. So this one can throw, say, can have a throw statement, but it's okay if the method that you are overriding in the child class does not have a throw statement. But the opposite cannot happen, right? So in the sense that you have your throws clause here, but there is no throws here. I mean, the reason for that is you can also call the super dot create clone, right? And if you are throwing it, uh, so here it's saying that there is no mechanism to handle it. So that's why you cannot simply throw it. You have to handle it within the create clone itself.
So can we put the throws clone not supported exception in both the methods?
Yeah, you can have it in both. That is
So,
okay. So you can have it in both, or you can have it in parent but not child. But the other way around is not possible. That means having it in child but not in parent. So that is not possible, and that gives a compilation error. So okay, that's the case 2. Okay, stream is freezing up. So case 1 was you have a checked exception, right? So and we just now discussed that it is not possible to do that. So case 2 is you have a it's not changing. Okay. Give it a few seconds. It has become pretty slow. Okay, let me try to do it this way. It might be able to change faster. Right? So okay, you have your case 2 where you are throwing a unchecked exception. So like I said earlier, unchecked exceptions are things that generally users cannot handle, right? Like memory error, or stack overflow error, and so on. So in this case, it is okay to throw it. So the parent class method need not throw it, but the child class method can throw it. So this works fine in the sense there is no, at least there will not be any compilation error, right? So you can do this, but you cannot throw checked exceptions in your child class method. Yes.
yeah. So why does this doesn't throw the error? Like this unchecked
So
exception.
unchecked, yeah. So unchecked exceptions are it anyway. I mean, most likely users cannot handle it, right? So we are only concerned with exceptions that can be handled by the user, right? So if it's a checked exception, it can be handled by the user. So if it can be, then you are saying that uh, it's up to the caller here. And in this case, you are saying that you're overriding it, but in the parent class method, you are saying it's not up to the caller. It will handle it by itself.
Okay, so
So
thank you.
in that sense, there is a mismatch, right? In one case, you are saying that it will be handled by itself in the method itself, and in the other case, where you are overriding it, you are saying that I will not handle it, but the caller will handle
Thank you, sir.
it. Okay. Okay. Yeah. So, any other questions? slow. Okay. So now let's look at a different aspect, which is creating your own exceptions. Right. So, like I said earlier, at the end of the day, this is simply a class. Right? It's an exception class, and if you have a null pointer exception, it's again a class, and you're creating an instance, and you're adding some message to it. So, in that sense, you can create whatever exception that you need. Right? So, for example, in this class, we want to create a no water exception. So the reason to create this is it's more intuitive, right? Like if you have an exception instead of no water exception, if you just have exception and in your message there's no water. Rather than that, if you create application specific exceptions, you can use it in your code, right? So for example, now you can say if E is an instance of no water exception, then you respond in some way. Or if E is an instance of null pointer exception, you respond in a different way. So that's why it's good to have application specific exceptions. And the way to create your own exception is by simply extending this exception class and providing a constructor, of course. This is a mandatory constructor. You should have a string, at least one string as the input, and then you simply call super.message. Then you can start using it in your other code, just like any other exception, right? You simply replace exception with no water exception. You can throw no water exception and so on. Right? Any questions? Okay, so let me move to the next one. Moving every slide is a hard task. Okay, please wait for a few more seconds and it should. Okay. So here, so you are creating this no water exception, your own exception. You can either catch it, or you can also use it in the throws clause. Right? In this case, you are saying that it will throw no water exception, and you are also throwing it. So the way to create that exception is you simply create an instance of the exception with a possible message, and then just throw it. Right? So it's pretty straightforward. So you can now start using your custom defined exception everywhere that any other regular exception can fit in, right? So that's in the catch block. It can be part of the throws clause, or it can be part of the throw. Create a new instance and throw it and so on. So it can be used everywhere wherever a regular exception can be used. It's slow. Sorry, my screen is freezing up every now and then. Okay, let me maybe. So in the meanwhile, are there any other questions? Oh. I think there are too many applications running on the machine. Sorry, please give me a minute. It settles down. Okay. Yeah, finally we have the new slide. So once you have this throws clause here, right? Now the implication of that is whichever method calls this get water, it either needs to throw, it also should have the throws clause, or there should be a mechanism to handle it. So in this case, drink water calls get water. Now, since get water has thrown the exception without handling it, drink water can either handle the exception here, or it should also throw it. So if it throws it, like I said earlier, it should be handled by the caller of drink water. So let's say there